Hi everyone, today we have a special guest, Bryan Braun, and we're going to be going over his Checkbox video player.
Hey everyone, I put together a library that I call Checkboxland. First off, Checkboxland is a way to render anything as HTML checkboxes. And when I say anything, I mean anything. So this could be data visualizations, animations, text. This could also be video, images, pretty much anything you can put on a screen, you can render it as checkboxes. Just a little bit of background. I was inspired by this because these physical displays where you have individual pixels that are mechanical and they rotate and they look pretty cool. And I realized that you could do the same thing with checkboxes. So this is a library. There's some cool demos here, things that I put together that you can make with checkboxes. Kind of fun to look at all of these. But ultimately, this is more than just a couple of demos that I'm showing off. This is like an entire library where anybody can use these APIs and they can make demos of their own. So again, we've got animations, we've got text, we've got, some of these are interactive, right? So for example, this one says, click me, you can click and it creates these sort of pulses that spread around. Lots of interesting things you can do there. And really, it's sort of there's not much practical purpose to this, but it's for fun and it's for creativity. And it's something that I enjoy working on.
The first question people will probably ask is, why do I want to use checkboxes for displaying this content?
I don't know if this is something that you would use for like a practical website. But for me, it's just all about creativity. It's like, what can I do with this? How far can I push these checkboxes? Can you make games with them? Can you make really impressive animations? There's a lot of agencies out there that are trying to get attention through, really splashy marketing campaigns and they push the web to their limits on what you can do. So why not try it with checkboxes? Maybe there's an application out there where you can get some attention and you can get some interest by what you're doing here. If not, then it's just something fun to work on.
Yeah. And there was also something that you showed earlier was the video of yourself. That's how I found out about this, was through your video on Twitter. And I was curious about if you could use the indeterminate state and how you could use that to then get even more fidelity with the checkboxes.
So if you look at like the API that I put together for building animations out of checkboxes, there's a lot of documentations here, but if you go and look at the API, you basically have the ability to put in ones and zeros to represent checked and unchecked states. But there's also this indeterminate state, right? So here's this one here that you can show 0, 1, or 2. And you just pass this data to the library and it will display those things as checkboxes. And having these three states gives you, I think, a little bit more flexibility as to what you can display. So the demo that you're talking about is sort of this webcam demo that I put together, and I can show that off here if you want me to.
Yeah, you go ahead.
Let's see if we can pull that up. We've got source code for all of these demos that you can look at. This is all on GitHub. So up on GitHub, there's all sorts of demos that I put together. And I think the one that we're interested in is this webcam test. So I'll just go ahead and grab the link to that. We're going to go straight to that demo.
That's going to use your webcam right now so we can see it live?
Yeah, sure. So again, we'll zoom this in a little bit. But I can adjust the threshold here and you can kind of see there I am with my headphones. You can see my CodePen t-shirt, and sort of me waving here. So that's the one that I made. But the more states you have, the higher fidelity this can be, right? Because like it's pretty limited, as you can see. You can't tell a lot of defining features about me. But we could make this higher resolution in a couple of ways. We could make the checkboxes smaller. We could use that indeterminate state. As you can see, we're not using that right now. We're just using the checked and unchecked. So yeah, there's a couple of options there. One thing that I ran into when I was working on this was different browsers can display these in different ways, and that can make it a little bit challenging. So for the indeterminate state specifically, if you're in Safari, then you kind of get this visual display where it's like a blue checkbox. It looks pretty similar to the checked one with this sort of minus sign in it. But if you're in Chrome, then it looks a little bit more like the unchecked one where it's grayed out. And I can kind of show that in the snake demo that I put together, right? In the snake, I wanted the indeterminate state to be like the apple that you're going for. And you can see it's a little bit harder to see here in Chrome.
So something you might not know if you're watching this is he's actually controlling that with the arrow keys. I was playing this a few days ago.
Yeah, totally. So as you can see, this indeterminate state, you could treat it as sort of like a light gray almost if this were like a color display. And you could use that light gray to make my webcam images have like another, like a pixel color almost, right? But then on Safari, it wouldn't quite look the same. It would look more like a bluer one. So that's one of the, and then on Edge, I think it looks different there as well. So that's one of the constraints that I was running up into. Again, there's a lot of uses for having a third state, like just like this snake example or other possible examples.
Yeah, it shows a different display. And there was something else you said that you could use the disabled state as well. Does that give you another 3?
Yeah, totally. So we have we have unchecked, we have checked, and we have indeterminate. And if you were to disable these, there tends to be like a grayed out version of each of those. And I mentioned that this was all on GitHub. This was actually a suggestion that somebody gave me the issues here. So we could actually take a look. We've got unchecked, checked, indeterminate, and then disabled versions of each of these. And, these are all slightly different looking, right? So you could treat these as 5 different shades, 6 different shades. And we even posited that you could get some images, right? Like this Mona Lisa, and you could kind of craft them together using all these different shades. There's a lot more you can do with checkboxes than we typically think of. And it's kind of cool to be able to play around with that.
Interesting. So let's take a look at the source code now and see how you actually got this working. I'm really excited to see what we're going to find out here.
So let's take a look at that. All right. So this was kind of a fun experiment for me. I got to jump into ES6 modules a lot. The source code is the demos that you see. They're not built and compiled. They're just running straight ES6 modules. And I think that makes it easier to work on and easier to read in a lot of ways. Really, we just have this JavaScript class that we call Checkboxland, and all of the APIs are really built into this. And then we're able to extend it and add, I think, plugins in order to get more higher level functionality.
So let's work retroactively and see what this looks like from a consumer standpoint, and then look at the source code behind the scenes. Because I think the first thing I'm wondering about is, if I'm going to use the Checkboxland library, what is it going to look like from that perspective? And then that should hopefully help me understand what's going on behind the scenes here.
Yeah, totally. Let's look at the docs here, because I think that'll help in that regard. Basically, if you're going to be using this, I have this basic example where you set up, kind of initialize a Checkboxland. You identify some div or some container on your document that you want the checkboxes to be populated into and the dimensions of your grid. And then you get this object that represents that grid. Then you come up with your data. So it's really just a matrix of ones and zeros, meaning an array of arrays. And you can kind of see the ones represent these checked areas and the zeros represent unchecked. And then we just set that data to Checkboxland. And on the screen, you'll see the representation of that data. So that's the most, I think, basic example of how you would use this. With that, there's a lot you can do on top of that. So we have, I think, this extended API, which makes it easy to do, I think, high level things, right? For example, there's this method called print, where you essentially give Checkboxland a string of text, and it will print those characters as text into the checkbox grid. This is something where you don't need to define every single checkbox, right? You can just give it the text that you want. And we have a demo of that. That looks pretty good once we can just pull it up here. Text box is what it's called. Yeah. So for example, I can change the characters and it will just display that text on the grid without me needing to worry about every single checkbox and giving it the full matrix.
So did you pre-program all these letters ahead of time?
Yeah, we basically have a font that's defined in the code, and it's based on these 5x7 bitmap fonts that they used in super early terminals and things like that. I think we, even in the source code, we can look up this font. I have a couple dimensions, but for every character, 1, 2, 3, 4, 5, 6, 7, I have that mapped into a 5x7 matrix. And capitals, lower cases, symbols, everything on the keyboard. I just put that together so you could do this kind of thing without needing to worry about every single checkbox.
What if you want to change the font size?
The size of the font? Yeah, so that's not really an option. What you would need to do is you would need to define a new font. So I have a different one here. This is like 4:11. It's kind of a skinnier, taller font. And this is just for numbers. I use this to make a digital clock, but you would just define your own font. And this API, this like print API that I made, there's an option for kind of giving it a font, essentially a JavaScript object that has this mapping of characters. And you could give it your own, and then it would print out your font.
I see. So you've built that on the lower level API.
Yes, exactly.
And that would allow you to have other characters like Japanese characters if you wanted to, but you define what the font is for your needs, and you can make them as big or small as you need to.
Yeah.
Yeah, that's really cool. And all of these extended APIs that you have for print, marquee, transition, wipe, all of these are built on top of the lower level APIs in a way that if I looked at the source code, I can figure out how to build my own extended API if I ever wanted to.
Yes, exactly. So in fact, we could even go, and if you look at the source code for Checkboxland, there is a place right here where you can see Checkboxland itself is just this one object, but then there's all these sort of plugins that I use to extend it, and then I export that as the library. So if you wanted to, you could build on the lower level API, you could build your own plugin, and you could extend Checkboxland in this very same way.
I see. I'm ready now to look at the source code. I'm really curious how this works.
Okay. Actually, before we do, if it's okay, this lower level API, I just want to point out a couple of things about it. They do very simple interactions like I just want to get the value of a checkbox at location XY, right? Just tell me, is it checked or unchecked? Or I just want to set the value of a specific checkbox at XY, and then I want to give you what value I want to set it to, right? Like these are very simple, granular interactions, right? And then get data is like, I want the whole grid, and set data is I want to set the whole grid. So these are, I think, very small things. And a lot of these APIs were actually based on, I was looking up APIs for, I think, pixel grids like this, right? And I was like reading the source code, and I was reading the APIs, and a lot of them work like this, where it's just like, hey, I just want to set the color on this specific location, or I want to get the value at the specific location. And it turns out if you have that, you can kind of build everything off of that.
And it's an array of arrays?
Yes, it's an array of arrays, and they index at the top left corner. So this is like position 0, 0 up here. And then you would go over with your X value and then your Y value downward like that.
I see. So it's row by row, and then each row has multiple columns in it.
Yep.
Yeah, just like how you would render in HTML.
Yeah, totally. Like a table or something.
Yeah, just like a table.
Yeah, so if you have the ability to get a single value and set a single value and do that, then you can build other things on top of it. So I have like a higher level, this extended API where you can do a marquee, and you can take any image and you can scroll it across, right? But if you like look at the source code for this plugin, it's just getting and setting individual checkbox values and it's looping over them, right?
So does it draw out the whole screen first and then draws another screen and then it draws another screen?
Yeah, so let's see, how does it work?
I feel like I'm getting CRT vibes here, where the scan line is scanning across it on every, is it progressive scan?
Yeah. So I have here's an example, right? Where it's just kind of moving across. It's like a whole grid, and once it's done, it'll cycle back through.
So is it that every frame of animation is going to be the entire grid being displayed immediately? It doesn't hit every DOM node individually, it hits them all at once?
Yes. So a lot of these animations, they work on an interval or a request animation frame. And I think this one is like an interval with 100 milliseconds. So every 100 milliseconds, we'll do a refresh and the checkboxes will advance in one position. So like in this marquee, you can tell it what's the interval number of milliseconds between each step in the animation. And that'll, I think, define how quickly it scrolls.
Yeah, I see. So you've done a lot of work to get these working. It's more than just the checkboxes being on and off. So one part of the code is a matrix, and then it allows you to individually target checkboxes or set the whole grid altogether. And then there's another piece of it that allows you to do these higher level functions on top of that, which allow you to do more of the graphical pieces.
Yeah, it can be kind of tedious if you want to go in one pixel at a time and define an animation, right? And you can have that power if you want it, but it can be kind of tedious. Sometimes you just want to say, hey, I'm going to give you a bunch of data and I want you to scroll the whole thing, and I don't want to have to worry about the scrolling, right? So that's what I think this extended API is all about. Yeah, this transition is another example of that, where it's like you think of it like two slides in a slideshow, right? You give it one slide and then you give it another slide and you tell it, I want to transition from one to the next. And you're not like defining every little detail of that transition. You're just giving it the two slides and saying, here's the direction of the wipe. I want it to go right to left. And then like if you were to see what that looks like, there's an example of that, I think right here, right? Where one of the slides says hello and the other slide says world. And you don't have to worry about all the details of that animation.
That makes sense. And all you're doing here is, in this particular one, is you're drawing an image and then you're doing a set. Well, you're not setting all of the data. You're setting individual checkboxes on an interval, but per column instead of per row.
Yeah, totally.
At a slower interval. Yeah, that makes sense. And I'm trying to think how you would do it where you have the letters scrolling. So you've placed all of them on a grid, but then some of the grid is visible and some of it isn't, it looks like, if it's doing a marquee.
Yeah. So on the marquee, you're not required to set the data like the size of the checkbox land, right? Whereas I think on some of these other ones, like the slides, it's like, yeah, you want it to be the same size as this grid that you set up. Marquee, it's like however big you want it to be, you can place that and it'll scroll through it.
Yeah, and does this have responsive stuff in it? And this is not really you, more CSS with checkboxes, but is it possible to set a variable font size that sets itself based on its relative position in the window?
Are you talking about like the grid itself being responsive or like the content?
The grid itself, isn't it? Is it possible to get all those checkboxes to resize the same and orient themselves in the right positions?
Yeah, I mean, that's a good question. I think it's possible. These grids right now are not very responsive. If you were to, I think, reduce the screen size, I throw a scroll bar on there as kind of the way that I handle it. There's more you could do. I believe that a lot of these browsers, they will support, like if we were to dig here into the checkbox size, like I could reduce the size of these checkboxes and the boxes themselves can be smaller, right? So if we were to do that and then we were to like change some other CSS to take out the spacing, you could get a more dense grid and that could work maybe better on a smaller device. So that's not an approach that I've taken so far. But I think to some degree, you could get some responsiveness that way.
And I mean, this is really meant to be a tech demo and not meant to be something you're using in production, but you've built it in a way that you could use it in production and you can extend it however you want.
Yeah, I mean, that's kind of the tongue-in-cheek part about it is like this API is so detailed and it's like too powerful for what this is like actually practically useful for. It was kind of an exercise in trying to build a really nice API, honestly, for like a front end thing. That was something that I really wanted to try out. You end up with kind of this like joke where it's like, I can't believe somebody made this, but there it is.
Yeah, the coolest part to me is the video, that you're able to do video and it represents it with checkboxes. It's somehow figuring out like a nearest pixel if it's dark or light based on a certain value.
Yeah, so there's some really interesting things about the video. It ended up being a lot easier than I thought it would be. And the reason for that is HTML Canvas. Yeah, I could actually pull up sort of an article that I was using to help kind of guide me through this process. And it helped me realize that Canvas can do a lot of this work for me.
Yeah, something I've done with images in Canvas before is actually render out thumbnails. You could save those to disk, but you don't have to. One of the things I did was save them out as thumbnails to make the thumbnails higher quality. So I had this very large image, and as if you know, the browser, when it scales it down, it gets all those artifacts and doesn't look as nice. So I used Canvas instead of image, and then I put that canvas render into the image as the thumbnail when I was doing it. And then you got these nice soft thumbnails instead of those hard lines that you would get.
Yeah. I thought that I would have to do some like super fancy, like resolution reducing stuff when I was going into the video. Like I was like reading articles about it and like I thought I'd have to be like, okay, I've got like these 9 pixels and I have to reduce it to these ones and I have to figure out like what are the colors of these and all of this stuff.
Yeah, that's what I was thinking you were going to have to do.
But what Canvas lets you do is they essentially say, hey, I can take an image, a single image, and I can reduce it to the exact dimensions of my checkbox grid, right? So if I have an image that's like 400 by 400, and I have this grid, which is like, I don't know, 16 by 42. What I can do, or I guess 42 by 16 in this case, what I can do is I can just say, hey, scale down my image to be literally 42 by 16 pixels. And then Canvas will scale it down for me. They will do all this like nearest neighbor approximation or whatever, and they'll scale it down for me. And then I just have to loop through each pixel of that canvas and say, hey, is this pixel black? Is this pixel white? If it's black, then make it checked. If it's white, then make it unchecked. And like they kind of do all the hard work for me, and I just really need to loop through it and represent it.
Are you able to run a grayscale on it as well?
Yeah. So that's part of this article that I was kind of pulling up. Is it was teaching how to do grayscale. They were doing it for like ASCII text, so you can do that. But in my case, I just wanted, I think, black and white, right? Two different representations. So they have like this grayscale formula where you take the red, green, and blue values and you kind of run it through here, and then you set, I think, R, G, and B basically to the same values, and you kind of grayscale it out, and then that's how it works. But for me, all I need to do is find some sort of threshold and say, hey, if it's greater than this, then let's call that gray black. And if it's less, then let's call that gray white, right? I just have to.
That's what I figured. Yeah.
Yeah. So like if we were to look at the source code for that.
Yeah, let's take a look. I'm excited.
It's funny, the rendering video and rendering images, they use the same underlying code because it's kind of the same either way.
Ah, I see. So it's this rendered media as checkboxes is the same function both use, except for one's using it more often?
Yeah, so like render image, it'll call it right in here. And then the render video plugin, it does the same thing. It calls it right here, render media as checkboxes. The only difference is the video does it on a loop, and it'll do it for each frame of the video, and image just does it once.
It's surprisingly fast.
Yeah, totally. But if you like look at what it means to actually render one of these frames, we get our media and we get our canvas, and let's see.
So let's draw image.
So this is a HTML canvas method. So we have this thing called context, and everything on context is part of the canvas API, right? We create an HTML canvas that cannot be seen on the screen, right? It's never put on the screen, but it's just there in our code, and we can put stuff on it and read stuff off of it, and we can just use that API for our own purposes.
So it's like having a monitor that you're rendering to, but it's not actually connected to anything.
Exactly. And that's nice because we can put our image on there, and we can tell Canvas, okay, scale it in this way and crop it in this way and resize it and do everything we want. And then we just read off the values that look exactly like our checkbox grid should look, right? So it does all the hard work, and we're just like reading and writing to it. But yeah, as far as like that grayscale stuff, so we essentially have, there's a lot of stuff around dimensions here, but really the interesting part is here in this black and white image data. And so we have a function down here where we have our grayscale function.
Oh, straight up right from that article.
Right from the article, we pulled the same grayscale function, and we pull the image data off of our canvas. And you can imagine this canvas as being like a shrunk down version where it's like one pixel for each checkbox. And then we have this to grayscale method, right? So what we can do is we can just put data in there and get data out. So we take our RGB values from the canvas, we put it in there, and we get a single grayscale value coming out of it. And then we just compare. We say, is it greater than our threshold? If so, we make it white. Otherwise, we make it black.
And that threshold is variable. So typically that threshold is 127.
Yeah. So I think we have that defined. There's a default value somewhere in here.
It was a calculated value.
Oh, calculated value. Yeah. So it's like 127, but then we expose it as part of that API. So if we were like to jump in here and go into these like render image, there's like a threshold value. We just like pass it in there. And in here, we represent it as like essentially a percentage, right? Mm-hmm. And like 50% of 255 is 127, right? Because RGB goes on this like 0 to 255 scale. And then it's nice that you can expose the grayscale, the threshold, like that range slider that I was using with the webcam. That's just this threshold being exposed and mapped to a slider. So you can play around with it however you want. I think, for best results, if you're displaying an image or a video, like the more high contrast that video or image is to begin with, the better it's going to look with checkboxes, right? Like my webcam and my background, like it's not a high contrast scene. Like if I were to turn off the lights in my room and then I'm like lit from the front, like it becomes a lot higher contrast and it looks a lot better that way.
Yeah, interesting.
Have you heard of the bad apple challenge?
No.
No. So I have a demo here that I could show you that uses video rendering. There's this, I think this sort of a music video from an anime called Bad Apple. And there's this challenge where people try to display it on all sorts of interesting things. Like, can I display this video on a TI-89 calculator? Or can I display it on my smartwatch or on my like Kindle display, right? And people will try to there's like whole YouTube playlists of people rendering this video on all sorts of different computing environments.
I feel like they're going to run into the same issues you're going to run into, is that they have to display a video using a fixed number of pixels that is much smaller than the amount that the actual video uses.
So you end up with resolution issues, and it's not quite as good as it did look. But I ended up doing this demo, and I could show you what that ended up looking like here. I think if we just go video.
Oh, so that's what this one is.
Yeah. So this is like, it's a video and you can't really see exactly what it's all about, but it's this animated video that people will often try to use to display other low computing devices and things like that.
Yeah. Yeah, I could see like somebody drop somebody and then that person singing again and dancing.
They're like dancing. Yeah. If you look at the original video, it's all in black and white and it's super high contrast, which is why you can see like the profile so well. And it makes like a good example for this kind of thing, you know?
Yeah. That's phenomenal.
Yeah.
Do you want to take a look at the source code now?
Yeah. So, we've talked about this low level API and we've talked about some of these other methods. Like, I think it might be kind of cool to look at one of these ones like this marquee.
Yeah.
And just sort of see how this runs, right?
Yeah, I'm curious how you get it to show the text and then the text goes off screen. My assumption is what you've done is you've assigned all of the text in an array. So this is me guessing right now. You've put all the text in an array, all right next to each other. And then what you're doing is you're basically saying what index to start drawing from in that array when you're sending it out. What column index essentially you need to start drawing from.
Yeah, pretty close. So let's take a look. So essentially we have data and we're passing it in.
Data is the array of arrays?
Yes, it's this array of arrays. And remember, it can be any size. Like it's this big, long piece of text in the demo. And then we have sort of the interval that we're using for each advancement of this data. This interval is running on a loop, and every 200 milliseconds, we run the code that's inside of this interval. And you can see what we're doing is we are looping through the number of rows and the number of columns in our original checkbox grid. And we essentially have a single column, which is representing, I think, like pulling fresh checkboxes is what I say here in my comment, but pulling from our data that we pass in, our new data. And then all other values are just being shifted, right? We're looping through and we're only doing interesting things if we are on the final column of our checkbox grid. If we're not on the final column, then all we're doing is we're just taking that column and we're advancing it once to the left. But if we are in that final column, here's where we're taking our source column of the original data that we were passed in here. We take that information from the source column and we're reading, okay, which column do I want to pull data from? And then I'm also kind of checking to make sure, like, is it undefined? Is it a valid value? And if so, we pull that value and we're using that kind of that lower level API to just set that individual checkbox into our marquee.
Yeah, I'm lost. I'm trying to figure out what's going on. Okay. So what is the final column? If we had to draw this out, could you say what that would look like?
Yeah, and I can show it to you here. So if we look at our demos up here at the marquee, we're really just looking at this column right here, right? This is the interesting column in the marquee.
Oh, that's the only column we're drawing something new in. Everything else is being shifted out.
Yeah. So when we're looping through, we're going, first row, second row, third row, and we're looping. And every time we reach a checkbox, we're just saying, hey, you go, I want to copy what's over here and place it here. I want to copy what's over here and place it here.
Oh, so we are doing a change.
We are doing a change. But it's just this one line of code that's saying, hey, take the data from the next checkbox and apply it to me, So there's not much going on for 90% of this grid. It's just saying, hey, I'm copying and pasting what's to the right of me, right? If we detect that we are in this one, in our loop, then we say, okay, I'm going to jump over to my source data and I'm going to say, okay, which column is the new column I should be pulling from?
Yes.
And then we pull the data from that column, and that's the one that we're setting into this like final column.
Right, so far I'm following. What's the data that we're passing in then? Is it the word checkbox or Checkboxland in this case?
Yeah. So we're looking at I think the marquee plugin right now. But if we jump over to like the demo code itself for this marquee demo, you can see that source data. So let's take a look at that. So we're using like the print.
Oh, so this is actually the marquee plugin is using the print function. Oh,
plugin
to make the text. Okay, so it gives you the text as a matrix.
Yeah. So now like this text data, this is like this huge matrix of ones and zeros for the characters Checkboxland. And like we could even, if we wanted to, we could like dump this to the console and we could look at those ones and zeros. But that represents our source data. And that's not actually what's being printed to the Checkboxland. That's just our kind of our reference that we're looking into to decide, okay, what's the values I need to print?
Yeah, so we're using the print function to create an array of arrays with the text in it, and then we're sending that array of arrays with padding, it looks like I can see it there, to the marquee function.
Yeah, a little padding.
Yeah, and the marquee function is keeping track of the last seen column that it was able to draw.
Yeah, exactly.
Okay, so where is it keeping track of that column? I didn't see it in there.
Let's take a look at that. Let's see, source column to draw. So what we're doing, so, and this changes, right? Depending on which iteration we're on. Like the very first, our source column is going to be like column number 1. But then on our next loop through, it's going to be column number 2, and then column number 3, and then column number 4. So we have this number of columns, and then we're kind of just keeping track of kind of our loops through, and we're advancing it with each pass.
Now, at some point you run out.
Yes, we do. It looks like that might be this like undefined, right? So we're checking in our source column, hey, is this undefined? And if so, we have like this fill value to fill the space until the animation is complete. And that's like, if you were to jump back over here, I think our last piece of data is at the end of this D, and we're just filling it with zeros, right? Empty space. And then when it's complete, we cycle back through again.
And does it know how long to keep it blank? It's the entire span of this. So it's basically until we have no data further.
Yeah. And you can see like there's not even any space in between. Like as soon as the last row leaves, the next row is back on and it's going again.
I see. So that's how it works. Interesting. That's how you've set up the marquee, but you could set it up to infinitely loop, right? Where it doesn't have that white space.
Yeah. And like there's not that much code, I think, to this marquee. Like if you look at this, it's just a single loop through the matrix. And then, we plus our iteration each time through. It's like 40 lines of code. And we could customize this however we wanted. I think this plugin is just kind of an example of like, this is how you could do a marquee if you wanted to do one.
Yeah, I think the interesting part is that it's using your other API, the print API, to make the data structure you need to then build out the marquee.
Yeah.
Because you could do the same thing with images and other things too. So you can use another plugin to create something that then is used by the marquee plugin to essentially span over the screen.
Yeah, totally. We do that a lot with like this on click. So this is a plugin that will essentially, if you click somewhere in the grid, it will tell you, hey, here's the XY value where you clicked. And that's super handy. This one, I didn't write this one. This was actually contributed by somebody on GitHub. They thought this would be kind of a cool thing to add. But it's just an event. You create this event listener on the grid. And then when somebody clicks, it finds the coordinates of that checkbox and it returns the X and Y value. And then it'll return like the actual checkbox element itself as well.
And is this one, so I'm actually curious about this too, is it doing recursive calls? Because it looks like it's getting a plus sign outside of where you click. So it's getting the 1y plus, 1y minus, 1x plus, 1x minus, and then it's continually doing that over and over until it fills up the rest of the grid from that starting point.
I don't think this is recursive.
Oh, this is a different one. My bad.
Yeah. So, you're thinking of that demo that we were showing where it was like kind of spreading out and stuff?
Yeah.
So this is kind of like the tooling under the hood for that.
Okay.
Right? Because all this does is it creates a listener, and then if somebody clicks, it hands over as data, here's the X and Y position where they clicked. And that's all it does.
I see. So it creates an on-click listener on every checkbox. When you do checkboxland.onClick, it's giving you a function that essentially listens to all of them and then tells you which one was clicked.
Yes.
That makes sense.
Exactly. And then that becomes useful if you want to do any kind of interactive demos, right? So if we go back over to that demo I think you were describing, and just to make sure we're talking about the same one, like this one here, I think, where like you click. Yeah. So this demo uses this on click because I want to know which checkbox was clicked. And like if we look at the code for this this pulse, you'll see that we're using that plugin for this other one. And I can just pull that up. The demo code here. Yeah, right here. So the cleanup part is not, I think, what's interesting. This is good for...
I see it. It's 3 lines up, 4 lines up.
Yeah. So, and again, I'm using print also, right? So I print click me in there, and then on click, I want to call this pulse function. And you can see, like, because I'm using this like Checkboxland on click, it just gives me an X and a Y of where it was clicked. And that's super handy because I need that in order to know where my pulse will propagate from.
Yeah, it looks like it's also doing an n-squared loop here, where you've got a loop inside of a loop, and every pulse, it is doing that within the interval. So it's not doing anything recursive, which is actually probably better. And then it's basically looping through every single one to find out which ones are nearby the one that was last changed. But you're going to have 4 of them that it's looking for. It's got to have 4 in here somewhere, right? No, more than 4 even. It's going to have how's it finding a list of all the ones that have been changed?
Yeah, so this does not actually use neighbors to determine like whether it should be checked or not. This is using, I think, a distance comparison function. So it's more of a mathematical approach, but this is visual. So I think it's kind of, it could be helpful to represent. It's really just like this X is greater than T. So if I hit like advance, then what's happening is you can see there's kind of like a leading edge, right? Which is kind of moving. And I just do this as like, this is like the force that's advancing, right? And then what I do is I use the hypotenuse. So I use...
which I didn't even know was a JavaScript math function.
Yeah, actually working on this is how I learned that it was as well. But I just treat every pixel as like this XY, I treat it as the origin of a circle. And like this distance is like an advancing circle. So when I run it through the hypotenuse, I can find like this generic distance to the origin, no matter which
is T.
Yeah. So T is like this distance, right? This distance to the origin. And I use the Pythagorean's theorem because if I can borrow this grid, you could imagine each item on this grid being a checkbox, right? And I can find the hypotenuse of the triangle to any checkbox, right? And that becomes like the radius of a circle, of an advancing circle. So there's probably better ways to describe it.
Yeah, it makes sense. And then at some point, you're going to notice that there aren't any pixels left to change. So you're going to notice that when you're doing your equation, your T has increased, but you don't have any, or your distance. We should use distance. T doesn't make any sense. Your distance has increased, but you're not changing anything. And so you probably have one step that it checks that, right? And then it starts over. Or actually, it doesn't start over in this case. It waits for another click.
Right. So this runs on every click, right? Mm-hmm. There's a different pulse for each click. So you could say that this, for each click, like this will just continue running until it's full. And that allows me to, I think, run multiple clicks at the same time, right?
Yeah. How do we stop it? Like, what's the end game here? That it knows, hey, I've hit every pixel possible with the max distance. Do we know the total distance from the point that it could go to, and then it just stops after that?
Yeah. So that's how does it stop? So there's these intervals. Yeah. So these are intervals. And I think this is where the IDs come in handy. So we have, I remember actually doing this. So okay. I use these weird symbols and it was an experiment.
Omegas.
Yeah. Omega and these ats. And I essentially keep track of which checkbox has been affected. So for each click, you can think of it as like, there's like a ground zero, which is like the first affected checkbox. And then they spread until every single checkbox in the grid has been affected by this pulse, right?
And then you clear it at the end of that. So that was that clear code you had. But the interesting thing is if you click a bunch of times, they're sharing the same set of changes.
They're sharing the same grid, but each click, it's like an event listener on a normal like web application, right? If you click a submit button and it has an event listener on it and you click it like 5 times in a row, like those are 5 different you could think of it as like threads. They're not really different threads, but there are 5 different pathways of code, right? So it's the same thing happening here. There's 5 different pathways of code, and they each keep track of how many checkboxes have been affected until they've all been affected. And then this is like, if there's no omegas that remain, it's completed, and then it clears its own interval, right? So there's no more.
It looks like it clears all of them at some point.
Yeah, that's for when it's on this page here.
Oh, okay.
Right? Because somebody could be in here and they could be like clicking and be like, oh, I've got like 500 different intervals, and then I want to switch to something else, right? That'll just like clean up all of them before switching.
Oh, I see. Okay, that makes more sense now. So you're saying each pulse is completely separate from the other. I saw you're doing something where you're storing the omega in an empty, a little bit higher up. Yeah, fill value omega right there on get empty matrix. I thought this was the same for each one. They're all sharing these values, but it looks like they're all having their own independent set of values that they're pulsing.
Yes. So,
okay.
Yeah, I really wanted like these pulses to be able to interact with each other and like invert each other. And like that was a tricky thing to figure out how to do, because if they're all sharing the same state, then how do you keep track of like what's been affected and what hasn't? So really they share the same render page, right? The same screen, but they don't share the same state. And this like pulse state matrix, which is keeping track of unaffected and affected, this is separate for each on click. Like I could click 3 times. In fact, I will click 3 times. Let's go over here and click once here and once here and once here. And there's like 3 different matrices that are keeping track of has been affected from their perspective, right?
I think the thing I'm missing is get empty matrix. What's that doing?
Yeah, so this is a utility method, and it basically just says, hey, we have a matrix grid. I just want an empty version of that. So I want like a JavaScript array of arrays that's all zeros, right? And it doesn't do anything. It's just, I want one, right? Give me a copy of like an X by Y matrix that I can do stuff with, right?
Where are you setting them to the @ signs?
Yeah, so that happens in here.
With a mutation. Okay, so we're mutating that. It's a local state regardless, so the mutations don't propagate.
We calculate for a specific checkbox, hey, should I be affected or unaffected? That's what these like omegas and ats are. We calculate, should I be affected or unaffected? And then that state, it just gets set right here to our pulse state matrix. And I think the same thing also happens. We toggle the checkbox here as well.
Yeah, so when we're toggling the checkbox, we're technically mutating the state of the checkbox land, but we don't care what the value was. We're just making it opposite of what it was before. And what's interesting about that is, so we're just toggling between 0 and 1, but the interesting thing about this is that something else could then come and change it after or right before we did that, and it doesn't matter because we have our own internal state for each one of these pulses that we're keeping track of, and then the checkbox state itself is just visual and nobody cares what that is. It just gets set to whatever ended up being after all these pulses.
Yeah, like I just toggle it and then I forget about it and I don't care anymore. You know, what this loop cares about is like its own internal state, which is this like unaffected and affected state.
Yeah, I think the coolest part about this design here is you've created a completely separate version, like almost like a virtual DOM for the Checkbox land itself, and that way you can keep track of your own logic without mutating the actual state of the checkbox land itself. You do change the state of the checkbox land, but again, you don't care what it is. You're just toggling values. You don't even care what they were or are going to be. You just toggle them.
Yeah. If you look at this, like this is like 50, 60 lines of code if you cut out like all the like boilerplate and stuff. But like behind the scenes, it's just like, it's these nested for loops. You're looping over the array and then you're getting and setting individual checkbox values. It's just built on that kind of basic foundation. And if you want it to be like this toggle state where things can like invert each other, like you could do that, or you could have it be more like, I think you were originally talking like this nearest neighbors approach. Like you could totally do that with the same nested for loop. You just be like on a given value, you'd be looking at the neighbors and then you'd be deciding whether to check or uncheck.
Yeah, and you do that with your own local state and then just setting something outside of you based on what your local state was set to. But then again, you don't care what the state is outside. You have your own local state, and that's what's determining what's going on outside. That's the coolest part about all this. And it allows you to do, it's essentially asynchronous, and you've got multiple asynchronous processing running at once on the same screen, modifying the values of the checkboxes. But because because you have a local state that you're managing, which is literally a copy of the actual matrix with all zeros in this case, or all omegas.
Yeah, literally.
Yeah, it allows a very good separation of concerns. I think this is actually a really well put together demo for how you can do separation of concerns on a matrix. It doesn't have to be just a matrix, but I don't even know how to explain it, what other use case you could use for this, but what I'm thinking is that this is a really good separation of concerns. It shows that local state is very important. You do all your logic on your local state. You don't care about what's out there, and when you want to do something on what's out there, you just call a function and let it happen, and it's out of your hands at that point. For instance, there could even be a lower level method that is toggle checkbox, and so you don't even have to set the state anymore. Because right now we do care about if it's a 0, 1, and we just toggling it. I mean, we're trying to keep the code a little dumb here where it doesn't know about it. If you look at line 55 there, what it's doing is it's toggling based on what the previous value was. So we do care in some ways what the value is, but we really don't care because we're just toggling it. And so if you wanted to add a toggle checkbox value behind the scenes, it would just toggle between 0 and 1. If it was 2, it doesn't matter, it just toggles between 0 and 1, and that's how you set it up.
Yeah, like that would totally be a very reasonable API addition to this. Like that's exactly the kind of thing that lower level API is for.
Mm-hmm, mm-hmm. Yeah, this is really cool.
I mean, it was a lot of fun to work on these things. I think the only thing that I still like think about is like this omega and at. Like I went with this because I didn't want to use ones and zeros because like that's what the like Checkboxland is using, right? And you could imagine there being confusion using ones and zeros to represent affected and unaffected.
Yeah, if we look at line 50 and line 55, the differences here between these are specifically you did those strings to make it clear for somebody else looking at the code that this is the local state versus the checkbox state.
Yes, we're operating on two different things here, both like different matrices, but then also different concepts. Like this is a checked and an unchecked box. This is an affected and an unaffected box, which could be checked or could be unchecked. It's like a different thing. Right.
Yes. So this basically means it's been touched or not from your...
Yes.
Yeah. That's a good way to put it.
Yeah.
I actually, in the form library I built for React, it has the same concept of there's a visited state, but that's separate from is the field able to be validated or is the field able to have a value in it. Those are completely different states versus something like, where you're talking about you have a checkbox being checked or non-checked, and then affected or unaffected could be completely separate. There could be other things in there too. You could put RGB values in there. It could be whatever you want to say what the state of each pixel is locally in your own pulse function. I like that idea. Now, I'm wondering if you had a toggle checkbox value function in your Checkboxland class, would you then use 0 and 1s here or true and false even? I would almost think true and false would work really well.
Yeah. I mean, you could use true and false. I think the 0 and 1s, they kind of lend themselves to extension, right? Like if we wanted to do indeterminate and disabled and, some of these other kind of states, you'd be able to support that. I think really the only reason I hadn't done a toggle state so far was there would be some edge cases around those indeterminate states, and you just have to be thoughtful about that. So, in this specific demo, I don't use indeterminates, so I don't have to, I could just assume, hey, this is going to be a 0 or a 1, and I don't have to kind of build that into the framework. But you could totally do it.
That's a good point. So this is more of an architectural discussion here, is that if you were going to add the toggle checkbox value function into the library, you would have to now consider, okay, if it's indeterminate, what happens? Do we want to make it 0, 1, or do we just leave it? And that would be different for everybody's use case. And so it doesn't really make sense to add that function to the library itself, but it does make sense to add that as something that you would use in your demo. This particular demo, it might be nice to have an extra method that does the toggle and then separates that from the actual logic that you're seeing here. And then you don't even have to know what's happening. You just know a toggle occurred. From there, it does something else. You don't even need to know what that code's doing.
Yeah. And if you did that, you could pretty easily change this so that your pulse has multiple different appearances, right? Like you could have your indeterminate checkbox be the leading edge, and then you could have like a trailing edge of a checked box, and then you would kind of get more of a different kind of look. That would, I think, look pretty cool.
Yeah, and have like a border on it as it went out.
Right. And you could change how thick that would be. And you would just need to change, right? This, you'd have this unaffected and affected, you'd add a third one in there, right? And it would represent, some other indeterminate state.
Yeah, that makes a lot of sense. Yeah, I mean, they could be the whole string too. It could be affected and unaffected actual strings. You don't have to use characters. Yeah, now I'm thinking about it. I'm like, maybe that would have been better. But yeah, I see where you're going for. The unaffected almost kind of looks like an upside down U, and then the at sign looks like at affected, with the A. It's just interesting.
Yeah.
Yeah, I can see where you're coming from, how you built this and how you're using it. There is still a lot of underlying technology when you're actually building something out, but you've provided a lot of good pieces to make it so you can pretty much do anything you want. Like you can build your own font and then just put it in there. It could be any language you want it to be. And actually, the game I made also used bitmap fonts, and so it would cut out all the characters, and you would tell it what the size of each character is, and then it would assemble them together itself. And that was the same kind of concept of what you're doing here. It's a little bit different though, because you're giving it a PNG of like a bitmap, and it has to figure out how to sprite that out itself. It makes a lot of sense how you're doing this, because it's the same kind of way you would do it in any of those older technologies where you're talking about you have a fixed pixel space of 80 characters. Now I'm wondering, you could do a whole console in this. If I wanted to program a terminal using checkboxes, I could probably do it.
Yeah, it's funny. This like logo at the top, like this is an interactive logo. Like I can check and uncheck this like it was a box. And like you could do typing, you could do a whole like form that you could fill out and like submit your email address or whatever. I think at some point you'd probably run into some performance issues, right? But you could do it. It's just a display at that point.
Yeah. So really, Checkboxland isn't as much a fun tech demo with checkboxes as much as it is a black and white monitor.
Yeah, with essentially 2 states, maybe 3 if you look at 6. Or 6, right? Yeah. And it's funny, like when I first made this, I felt like that was obvious. And I'd made like 1 or 2 demos, and I would like share it with people, and they're like, that's cool demos. But like, it wasn't until like I made more and more of these images and videos and all these things that people were like, whoa, this is really cool. Like you saw that webcam demo.
Yeah.
Like this library's been around for like a year and a half or so. And I've just been slowly making more demos, but it wasn't until the webcam one like got really big on Twitter that I think it got a lot of attention.
I see. I didn't know that. Yeah, I mean, that's where I saw it.
Yeah.
I thought that was a really cool demo, and it brought my attention to this really neat way of using checkboxes, but also the JavaScript behind the scenes used to render it. And the way you've done it is really interesting. Most of the important piece of information has all been done through Canvas.
Certainly on the video and the images, we just lean on Canvas for that.
Yeah, but the rest of this technology can do cool stuff too. I'm really excited to see people take this in a different direction and see where they can take it, because it really is a monitor that you've put in JavaScript, and you don't have to code it yourself, and it's working with HTML technologies. If you were to do this with divs and you put a bunch of squares there, you could probably get it to work that way too. But having this whole idea of a checkbox of just being on or off and having that built into the browser means most of the work's been done for you, and it's just standard HTML at that point.
Yeah. And, one thing I really like about the checkboxes is they kind of beg for interactivity, right? Like when I show some of these demos to people, like the first thing they want to do is click one of these checkboxes and see what happens.
Yeah.
You see this ripple and you're like, well, what would happen if I click one of these? Right. And I think that's something that you don't normally get with a screen, right? Any kind of screen made out of divs or a canvas. So that makes things like this pulse, like it just makes it a little bit more fun, because like you feel like you're drawn to click it, whether or not it says the words click me.
Yeah.
So you can make any animation, and then you can kind of add some surprise to it by allowing that animation to respond.
Yeah. Yeah, it's really neat. Have you seen any uptick in usage of this since you posted that on Twitter?
Let's see. Well, I mean, one thing that was kind of fun about the webcam is it's so easy for people to like use the demo and do their own webcam. So I would see like a lot of people who were like waving in their webcam, and they were like adjusting it. There was one person who they were applying colors. Like there's an API, sort of a new feature that you can use to apply accent colors to checkboxes.
Oh, yeah, yeah.
So they actually like used those RGB values and used it as like CSS to color each individual checkbox. And then at that point, it's almost like you've got a color display made out of checkboxes. So that was kind of a cool thing that I saw someone do.
Yeah, that's really neat. What's your thoughts on how you've been working on this library and then suddenly people find out about it? How's that feel?
It's one of my favorite things about, doing some open source stuff. Like I've got other open source projects as well. This is perhaps one of the more creative or I think fun ones that I've done, but I'm always just amazed when other people actually like download my stuff and try it out and use it. And it's one of the most like, I think, fulfilling things about having this kind of career, just seeing other people run with stuff that you've worked on.
Thank you for showing Checkboxland to us. Do you have any final comments?
What I would say is just like, it's not something that I consider to be very practical, but it's fun, And I think earlier in my career, I wanted every single thing I did to be like, oh, this is going to move my career forward, or this is going to be really useful. And I think I've gotten to a point where it's like, we should just do fun things too. And it's motivating to work on things that are fun, and the world needs more fun things. So whether it's this or something else, I think all developers should make a little bit of space in their life to try some fun things.
Yeah, thank you very much.